So your next topic is your pre-envelope. Okay, so what is meant by pre-envelope? If you consider a real valued signal x of t, then the pre-envelope of the signal x of t is defined as the complex valued function in which the real term will be equivalent to your same as that of your x of t, and your imaginary term will be equal to that of your Hilbert transform. In this case, this is your real value, and here x of t is your real valued signal, and x cap of t is nothing but your Hilbert transform signal. That is what given here, x of t and x cap of t. So let us take this equation as equation 1. Okay. So in general, the pre-envelope of the signal is useful in handling your bandpass signal and system. So if we take the Fourier transform of equation 1, what will you get? X plus of t will be converted into capital X plus of f is equal to capital X of f. Okay, plus j into capital X cap of f. So already in previous video we have seen what is your X cap of f. X cap of f is equal to what is the value? X of f into minus j signum of f. You have to just substitute this X cap of f in this previous equation. So what will you get? X plus of f is equal to x of f plus j into, instead of x cap of f, you are going to substitute this value. So x of f into minus j signum of f. Okay. So when you cross multiply this inside, you will be getting x of f will remain as such, plus this x of f also will be remaining as such, minus j into j. You will be getting minus j square into signum of f. So you know that what is the value for minus j square is equal to plus 1. Okay. So what you will be getting, this will go to 1. So what you will be getting, x plus of f is equal to x of f plus x of f into signum of f. Okay. So now you can again, this is taken as equation 2. Actually this equation again you can simplify it into, you can take it as x of f as common, right? X of f into 1 plus signum of f. So this will be your equation. X plus of f is equal to x of f into 1 plus signum of f. Okay, or you can write this x plus of f in terms of 2 into, for different frequencies, f greater than 0. So if f greater than 0, if I substitute f is equal to 1, what will be? You know that signum of f is equal to 1 for f greater than 0, minus 1 for f less than 0, and 0 for f is equal to 0. So if I take for f greater than 0, if I substitute the value of 1 in this equation, what you will be getting? X of f into 1 plus 1. So you will be getting 2, right? 2 into x of f. That is what written here. Okay. So x plus of f is equal to 2 into x of f for f greater than 0. For minus 1, what will you get? That is for f less than 0, what you will be getting? You will be getting x of f into 1 minus 1, right? So here signum of f will be equal to minus 1. So 1 minus 1 is equal to 0. 0 into x of f, you will be getting it as 0. So that is the reason for f less than 0, you are getting it as 0. So for f is equal to 0, your signum of f is equal to 0, right? So x of f into 1 minus 0, you will be getting it as 1, right? So 1 into x of f, it is x of f. So but you know that f is equal to 0 in this case. So you will be getting x of 0. This is how you are getting this equation. Okay. Now what is the next? So x of 0 is the value of x of f at frequency f is equal to 0. Okay. Now let us take this as equation 3. So as I have mentioned before, the equation 3 shows that the pre-envelope of the signal has no frequency content for all negative frequencies. So this is actually your for positive frequency, right? See here in this expression, for negative frequency the value is equal to 0. Means what? It is not having any frequency component for your negative frequency. For example, if you take the amplitude spectrum of low pass signal, so you know that x of f, magnitude of x of f minus w to plus w, right? So you don't have your negative frequencies. For negative frequencies, your value is equal to 0. So the pre-envelope will be equal to, if I take the pre-envelope of the signal, okay, the spectrum of the amplitude spectrum of the pre-enveloped signal, then what you will be getting? You will not get your negative frequency term. It is equal to 0. So you will be having only your positive terms. Okay. So for f greater than 0, what will be your value? Here it is 2 into x of 0. So this is the specialty. So you have two methods to obtain the pre-envelope of the signal x of t. One is called as your time domain and the other one is called as your frequency domain. So in this is for again it is for the same case, okay, positive. So your that is for x plus of t. So x of t in the case of time domain, how will you get? It is the same expression, x plus of t is equal to x of t plus j into x cap of t. That is the direct equation which we have written in the first step. Now in the frequency domain, how will you find out your x plus of t? In the frequency domain, you have to follow three different steps. First step is you have to find the Fourier transform of x of t. Second step, you have to find out the pre-envelope, and the third step you are going to take the inverse Fourier transform. Okay, so if you take the Fourier transform of x of t, you will be getting it as x of f. So your pre-envelope will be equal to, in frequency domain, what is your pre-envelope? 2 into x of f for f greater than 0, right? And step 3, if you take inverse Fourier transform of x plus of f, that is x plus of t, you will be getting, right? So when you take inverse Fourier transform, you can get back your signal. So x plus of t in time domain is equal to 0 to infinity, right? 0 to infinity x plus of f into e power j 2 pi ft into df. Okay, so you can take what is the value here? X plus of f is equal to, you have for f greater than or equal to 0, greater than is equal to 0, 2 into x of f, because you have only positive values, right? So 2, I am taking it as constant, 2 into 0 to infinity x of f into e power j 2 pi ft into df. Okay, so these are the two methods. Now till this much time we have studied for positive frequencies. Now you can derive the expression pre-envelope for your negative frequency also. So pre-envelope of the negative frequency is just the opposite to that of your positive frequency. There it was plus, here you are going to give it as minus. X minus of t is equal to x of t into, there it was plus j x cap of t, here it is also a complex conjugate of the equation 1. Okay, so x plus of t minus j into x cap of t. Now you know that it is also represented as x minus of t. Since it is a complex conjugate, you can represent the conjugate, that is x plus of star into t. It can be expressed in this way also. Okay, so now proceed with the same formula. So what you will be getting? Fourier transform. When you take the Fourier transform, what you will be getting? X minus of f is equal to same method as that of your previous. Okay, so you will be getting x of t will go to x of f minus j into x cap of f. Already you know what is x cap of f, x of f into minus j signum of f. So what will be your expression? X minus of f is equal to x of f minus j into j. You know that what is the value? It is, here it is plus j square, right? Plus j square is equal to minus 1. That is why you have got here as minus signum of f into x of f. Here also you can reconfigure this. You can take x of f as common. So you will be getting x of f into 1 minus signum of f. Okay. So now if you substitute this value, you know that signum of f is 1, right? Signum of f the same as that of the previous. It is the 1 for f greater than 0, minus 1 for f less than 0, and 0 for f is equal to 0. If you substitute this value, what you will be getting? For f greater than 0, what you will be getting? The value is equal to 1. So 1 minus 1 you will get here 0. 0 into x of f, 0. For f greater than 0, you will be getting the value as 0. For now f is equal to 0, what you will be getting? The value is equal to 0. So signum of f is equal to 0. So 1 minus 0, it is 1. 1 into x of f is equal to x of f. So f is equal to 0. That's why you have got here x of 0. Whereas in the case of negative frequency, that is for f less than 0, the value is equal to minus 1. So 1 minus of 1, you will be getting 1 plus 1, which is equal to 2. 2 into x of f. So for f less than 0, here the value is equal to 2 into x of f. So if you see at this expression, you can see that for your negative frequency, what is happening? Your f greater than, that is a positive spectrum is absent, right? So it will be just the opposite. If I take the low pass signal, okay, spectrum, and if I take its pre-envelope in the negative frequencies, that is x minus of f, then what you will be getting? You will get only your negative spectrum, and you will not be getting in the positive frequency, you will not get any signal. Okay, so here it will be 2 into x of 0. So here it will be minus w. So just the opposite to that of your previous signal. So equation 5 shows that the pre-envelope of the signal has no frequency content for positive frequency. The pre-envelope x plus of t and x minus of t are complementary pairs of the complex valued signal, right? So this is all about the pre-envelope of the signal. In